Here is the video for the final video for section 4.3, and we just really only had one more example, but YouTube only allows me to go up to 15 minutes, so I had to cut it off. I didn't have time to finish this one. So number 7, a box has dimensions 2 by 3 by 4, and it says to see the illustration. And if we look at the illustration, we see that eventually what we need is we need the triangle that has angle theta, and we can do a few of the calculations. For example, this angle, or this side right here, will be the diagonal of the side that has 4 and 3. Well, the diagonal here, if we look at this, this is a 3, 4, 5 triangle, so this length would be 5. That's easily calculated. This side right here is the diagonal of one of the sides that has sides 2 and 3. This one's not as easily calculated, but once again, the law of, or the Pythagorean theorem, gives us the value. This diagonal would be what? Square root of 9 plus 4, which is square root of 13. So this would become the square root of 13. And then the final one here is the side that is the 2 by 4, the diagonal of that. And so the angle here would be the square root of 16 plus 4, the square root of 20, which actually does equal 2 root 5. And so that's the length of this side right here. And then we're asked what's theta. Well, this is a side, so we can very easily use the law of cosines to find just theta, and that becomes the very important angle. Since that is the important angle, then the side opposite becomes the important side. So we get 2 root 5 squared equals root 13 squared plus 5 squared minus 2 times root 13 times 5 times the cosine of theta. Now, since we're eventually going to go to decimals anyway, truly at any point in time would this be acceptable to do so, but I'm going to hold it out until we get everything to one side and then take the arc cosine. So 2 root 5 squared will be 20. Root 13 squared is 13. 5 squared is 25, and this becomes 10 root 13 cosine of theta. Adding these two together and subtracting it from both sides, let's see, looks like it gives a negative 18 equals negative 10 root 13 cosine of theta. Dividing both sides by negative 10 root 13, so that the cosine of theta would then equal, let's see, 9 over 5 root 13. And there's really no need to rationalize, because what we're going to do is we're going to punch it into the calculator anyway. And so all we need to do is take the arc cosine of both sides. The arc cosine of 9 over 5 root 13. And since this is an angle, and it says specifically round your answer to the nearest degree, so we just need to take the arc cosine of 9 divided by 5 root 13. And that equals 60 degrees. All that work to get what should be, at this point in time for the semester, a very common angle. That's all we have for this particular video, so I'll see you in section 4.4.